Like Natalie was saying, I wasn't meant to be here, and so I put together this presentation last week, but it's actually been really useful because it's forced me to confront my demons about missing data in biosocial surveys. So I'm finding this really useful. I hope you do too. The substantive topic is around what we can do to improve stress at work. So things can get stressful at work, and hopefully we all have better managers than Dilbert's manager here when we complain about stress at work. And so one idea I had is whether if you had more flexibility around your working conditions, like how, when, where you do your work, does that reduce is that associated with lower stress levels? Now we can measure stress in many different ways, and the biological, physiological response to stress is one particular way, and the concept of allostatic load is basically it's an indicator of chronic stress reactions, dysregulation in people's stress responses. And in biosocial surveys, in social surveys like Understanding Society, we can get at this very multidimensional concept through a range of different biomarkers. And there are different ways of measuring allostatic load, but the original and perhaps the most common way is just basically to get a risk cutoff point for each of these biomarkers and then add them all up. So a higher score on this allostatic load index indicates more chronic stress dysregulation. So I did some analysis, I submitted the paper, and I thought I got some nice associations here in Understanding Society. So women who had 2 or more children, that's on the right-hand side, who were working in jobs where they could reduce their hours, they had lower levels of allostatic load, so that's the green bar, compared to women, women of the same peers, who also had 2 or more children in the blue bars, but they were not working in jobs where they couldn't reduce their hours. So having the flexibility about reducing their hours seemed to be associated with lower allostatic load amongst a group of women who really needed to reduce their hours, because it can't be easy to do a full-time job if you have 2 or more children. So that's the correlation that I found. I submitted, and I got a revise and resubmit because, well, many reasons, but one of them was, what do you do about missing data? And the missing biomarker data in particular, and also a very tricky comment around, how does this missingness impact on the estimates? So, what I actually did was I did the lazy thing. I used the survey-derived blood weights. So it's derived by the Understanding Society team, and I said, well, that does that's my method of compensating. But I didn't do any comparisons like you've been hearing the rest of the presentations today. But the second bit is I found it really tough to try and think of whether and how the missingness would impact on the estimates. So the rest of my presentation is really about trying to get at what do I expect to happen when I compensate for the missing biomarker data. Now Alex has gone through the Understanding Society biomarker data collection and the potential sources of missingness. So we start with around 36,000 people who are eligible for a nurse visit from both the UKHLS and the BHPS samples. And that reduces to about 13,000 who have got bloods collected. And in my particular analysis, it reduces even further to 6,000, but that's because I'm only interested in employees, people who are currently working right now. So basically the big drop is from 36,000 to 13,000. And the major sources of missingness is, as Alex said, a lot of people didn't refuse contact with the nurse. Either there was no contact or they actively refused to have a nurse come and visit them from that original 36,000 or so. So that's about 42%. And then the second group, about 20.5% who had the nurse visit but refused to give a blood sample. So that reduces out of a population of 36,000, only 37% had a nurse visit with a blood sample. There were lots of there's lots of information about the group that refused to give blood from Understanding Society. And so the nurses asked, well, why don't you want to give blood? And the top reason is because lots of people fear needles. Some people say they've had a recent health check, or recent blood test, so they don't want to give blood again. People don't like giving blood because they've had previous difficulties. So again, it's a fear of needles kind of reason. Some of them are a bit suspicious, so they don't have enough information on what the blood will be tested for, or they don't get enough feedback. Illness plays a little bit of reason, fear of HIV, not much. But of course, this kind of data we only have on the people that are not giving blood. We don't have this data on the 42.4% who don't take part in the nurse visit. So ideally, we'd want to look at some auxiliary sources of data coming from the main interview or main interview observations that sort of predict this kind of differential pattern of response. Now, Understanding Society has got lots of potential sources of auxiliary data, including a lot of interviewer observations. Yeah? So this is coming from the main interview, not from the nurse visit, but from the main interview that everybody that takes part in the nurse visit has had. And so some of the interviewer observations, like the respondent was suspicious or the respondent was corroborating, does seem to predict whether or not somebody gave blood. So I broke this down into people that had the references, those who had no contact or refused the nurse visit, and then the middle column is those who took part in the nurse visit but did not give a blood sample, and then the final column is those who did give blood. So those people who were more suspicious, there seemed to be no difference between whether or not they took part in a nurse visit versus taking part in a nurse visit but without a blood sample. But suspicious people are less likely to give the nurse a blood sample. Similarly, those whose understanding, remember these are interviewer observations, the respondents' understanding was not so great. They're also less likely to give blood. Then, in terms of cooperation statistics, well, it seems to be similar. The effect of not being very cooperative seems to reduce your chances of either having a nurse visit or giving blood. And in terms of these two health variables, I picked them out because I thought they showed very different processes. So people who've had a history of cardiovascular disease are more likely to participate in the nurse visit without a blood sample compared to the non-responders, but they're as likely to give a blood sample compared to the non-responders to the nurse visit. But in terms of clinical depression, it's going the other way around. So people who are more depressed, who have a history of diagnosed depression, are more likely to give a blood sample than those who refuse a nurse visit. So we've got potentially different sources of missingness patterns, depending on whether or not somebody just takes part in the nurse visit versus somebody who gives a blood sample. And that's what Alex was also hinting at was also saying in his presentation. Now, as I said, I used the Understanding Society derived weights to compensate for missingness, and they have very, very detailed and rich sources of data to derive these weights for different types of missingness, including people who don't give blood. They derive it both from the survey as well as from geographical contexts. And here's some, but not all of these variables that they adjust for in their models. It's a range of social, demographic, and economic indicators. I didn't see any of the main interviewer observations here or these kinds of differential health responses. So maybe, so that was one idea I had. So, can I do better? Does those derived blood weights from Understanding Society adequately capture differential missingness mechanisms for blood collection? What other sources of auxiliary information can we use? And these last two questions actually derive from my reviewers for that paper. Does it make a difference to the substantive estimates? And will the correlation between my X and Y, my flexible working conditions and allostatic load, will that increase or decrease? And I found that the toughest thing to do in advance. So I went back to, I'm not very good with equations. I like DAGs better. And you've seen this throughout this morning as well. So it's a slightly more elaborate form. So as I said, I used a survey-derived weight. So that's a missing at random approach to compensating for missing data with auxiliary variables denoted by A. So it's a method for compensating for the fact that Y is incompletely observed. That's why it's in a dotted square. So even when Y is incompletely observed, we can sort of try to get an unbiased estimate of the effect of X on Y. And just breaking down a little bit into the missing completely at random approach, we've got this missingness mechanism, this random thing that is affecting the chances of completely observing Y star, but there's no correlation between X and Y. So the effect of the association between X and Y is completely unbiased. And when we're doing some sort of inverse propensity weighting method, for example, we first estimate the model of the probability of response being conditional on auxiliary variables, on our X variables, and from that we derive the response propensities and take the inverse of that to then to estimate the effect of X on the effect of Y. The effect of X on Y. Yeah? So we use the inverse of those response propensities to model that. So, I mean, you've heard about that so far, but what I was trying to get at was what happens to the mean of Y, for example. And so it makes sense that if there's a positive correlation between the response propensities and the Y variable, then the mean Y will be lower in the weighted analysis compared to complete case analysis. So, in this case, people who respond had higher levels of allostatic load. So that means the non-respondents had lower levels of allostatic load. So if we adjust for that in our weighting process, then the association our Y values should be lower in the weighted analysis. And so in the reverse situation, if the correlation between the response propensities and the Y variable is negative, then the mean of Y should be higher in the weighted analysis. And this is actually the situation in George's analysis. So in George's analysis, the X was low wealth, the Y was cortisol, and she actually observed that in the weighted and multiple imputation estimates, the intercept for the cortisol is actually higher compared to the complete case analysis, and that's probably because the response propensities were inversely correlated with cortisol, and that kind of makes sense because she was looking at people who with poorer health being more likely to be non-responders. Yeah, so people with poor health. So the auxiliary variables there in that situation was poor health was correlated with non-response. So the responders were healthier. Yeah, and so that means that the healthier people, they tended to have lower levels of cortisol. So that framework kind of makes sense in why gives us an expectation of what the intercept of our dependent variables should look like in the weighted compared to complete case analysis. Now, how does this affect the association between our X and Ys? And here we also need to consider the correlation between our X's and response propensities. So once again, if we've got a positive correlation between both our X and response propensities and our Y and response propensities, then adjusting, it's just like any multiple regression analysis. If you've got a covariate that is positively correlated with both X and Y, then the association between X and Y should decrease. So that was something that should happen. the response propensity is accounting for some of the correlation between X and Y. And if we've got different signs for these correlations, then potentially we've got some sort of suppressor effect going on here. So our weighted estimates of the association between X and Y could potentially increase. So I plugged in those values. Yeah? So I didn't have an expectation in advance of what's going to happen with my substantive association, because I found it really hard to predict, given these weird correlations that I was observing. So clinically depressed people were more likely to give a blood sample, but those with cardiovascular disease were more likely to have a nurse visit. So it was really hard, and we've got so many of these auxiliary and covariates predicting the response propensities. It's really hard to come up with a theoretical framework about what to expect the sign of these correlations. So I just plugged in the observed values. So first of all, I used the Understanding Society derived blood weights. So I took the inverse of that and just looked at the correlations between my X and Y. So we've got a positive correlation between those response propensities by the blood weights with allostatic load. So in the weighted analysis, I would expect that the mean allostatic load should reduce. And also a negative correlation, or negative but very small correlation between my X and those response propensities. And so I would expect that the association between lack of flexibility and allostatic load should actually increase in the weighted analysis compared to the complete case analysis. So that was very easy to do. I just had to plug in those values that the survey had already derived. So I thought, okay, let's try and do something better, I thought. So let's plug in those interviewer observations, the different kinds of health dimensions, as well as all the sociodemographic factors that Understanding Society has used in deriving their weights. And let me derive a new sort of response propensity weight here and take the inverse of that, but also I have to multiply it with the survey weights, so the sampling weights derived by Understanding Society, not the blood weights, but of course to make the sample representative of the UK adult population, Understanding Society does have these base weights that I used, and I got very similar correlations with the Understanding Society blood weights, and that's unsurprising because this response propensities that I derived was highly correlated with the blood weights that Understanding Society provides. So does it make a difference? It certainly makes a difference to the intercepts. So the mean allostatic load for the complete case allostatic load is much higher. So they're more stressed than either the Understanding Society derived blood weights or my own blood weights. So those mean values are much lower, and that's what we would expect, because according to this correlation, there's a positive correlation going on between the response propensities. So those who responded tended to have higher allostatic loads. So once we adjust for that in the weighted analysis, the intercept, the mean allostatic load reduces. And does it make a difference to the substantive correlations between the X and Y's? It makes a little bit of difference. So it goes from 0.1 in the complete case estimates. The coefficients increase to about 0.14 or 0.13 in the weighted analysis. So it hasn't made a huge difference, and one of the reasons is it's a really small correlation going on here between the X's and the response propensities. And I think that's one of the puzzles here, that very often we're doing all these very fancy methods for compensating for missing data, and it should make a difference. It should make a difference to the Y's, because it's very hard to imagine there's a completely random process that is driving the patterns of missingness. So there should be a correlation between the response propensities and the Y variables. What is hard to imagine in advance is what is the correlation between our X's, our substantive X, and the response propensities. That bit is really hard to imagine in advance, and very often it's quite a low correlation. So if there's a very low correlation between the X's and the response propensities, then it's not going to give us very, very different results compared to the complete case estimates. So just to summarize, Understanding Society does have really great sources of auxiliary data, like all social surveys. So it would be really strange for missing data analysis using biological data not to try to find some attitudinal or behavioral survey data that is correlated with the missingness process. And I'm finding that it does, taking account this kind of auxiliary data does make a difference to the estimates of Y and perhaps to the correlation between X and Y. And in this particular analysis, I found that the correlation between lack of flexibility at work and allostatic load actually increases compared to the complete case analysis. So it looks like we have differential missing data mechanisms for blood-based data collection compared to just a nurse visit. And we should try to take this into account by using auxiliary data to look at these correlations. And we should be incorporating this auxiliary data into methods for compensating for missing data. And this association between X and Y will change depending on the correlations between X and the response propensities and Y and the response propensities. Now, I just want to end on a note on saying that that very often I read, I do a lot of health research, so very often I read so many studies that say we did multiple imputation, but it made no difference at all, so we're just reporting either the complete case or the multiple imputations. And I find that really hard to believe because definitely the intercept for Y should change. So I mean, if the intercept for the Y doesn't change, then there's something wrong. You just the models for predicting non-response probably aren't very good models, and they haven't really looked properly. But the other thing is that for the correlation between X and Y to change, yes, we do need quite a strong correlation between the response propensities and X's. So I think that's one of the reasons why very often people don't find differences. It's in the associations, and that's because the correlation between response propensities and our substantive X variables is not very strong. Thank you.